Alright everyone, in the previous video I explained how to transfer that geometry that you see on the screen right now, which is basically a 3-point arc. I show you how to make a Revit family. In this one we're going to work on a little short stubs. There will be a different type of family, and I'm also going to add a small wrinkle to the process by exporting some parameters for each one of them that we can later use in documenting it. So let's delete all this because the update function doesn't work yet. So we want to kind of clean slate every time we're going to be importing stuff in. So let's clean this out, and then let's go back to our Grasshopper. So this is our previous function that we've been using. It basically exported all these vertical framing members. So the next thing we want to do is we want to pull in all of these pieces, all those little short stubs in there. So what we can do is select them all, and then double click on the canvas, bring in the curve, and then right click, set multiple curves. So that brings into Grasshopper, that references back into Grasshopper all those short stubs that I've created. So you can see them, they all reference into Grasshopper now. Okay, once we have that, next thing we want to do, we actually want to create, since they're all straight lines, we can check that by sending them through a line component. And listening to what happens. Basically it tells you that each one of them is a line. So we can make that out of two adaptive points in Revit. So to make two adaptive points in Revit, we just need a start and end of this line. So we will do endpoints. You can find that under curve, analysis, and then endpoints. So we'll grab the endpoint of each one of them, and then important part of this is to make sure that each one of those endpoints is grafted. So each one of the little curves becomes its own branch on the tree. So here's the difference. If it was grafted and if it wasn't grafted. So this is what they would look like. So with the ungrafted one, we just get a list of all the studs that we all the lines that we referenced in. With the grafted one, each one of those curves gets its own branch. So this is what we want. That's why I'm grafting them on the input for curve, so that we get a start and end point for each and every one of those. And then all we gotta do is just weave. And I'm always double clicking on canvas to bring up the search keyword, and then you can just type in the component that you're looking for. So I'm looking for weave. So you bring those in and set your P parameter for 0, 1 to weave those starting points. So what that does, it takes the start and end point and puts them on the same branch. And then I will just simplify that to keep those branch numbers. So basically to delete useless branches because they don't really do anything. So they just extra computing time. So once we have that, again we have to multiply everything by that factor to convert everything from millimeters to feet. So I'll just copy paste, and then that will give me all the points in feet. So now this will be a different family and type. So let's go to Grevit and bring in a different adaptive component, because this will be a 2-point. This one's a 3-point arc, remember, and this is going to be a totally different one. This one's going to be, let's just call it a 2-point line. It's going to be a 2-point line that we're going to be using, so let's make this family and type the same, and then the points that we're going to be using are here. And then if you hold shift and then connect that to here, we can bring in both of those geometries by just hitting the send button once. But for the sake of, like, so that will be it basically, and then we just have to build the Revit family. But I also wanna show you how to send some parameters with it. So let's say that you don't want a dimension, or you want to schedule a length of that line in the schedule. So what I would do is I will measure distance between those. So let's collect those points and measure distance between the start and end point. So you can type in distance between start and end, and then again we have to convert it to feet. So that will be our distance. Another thing worth mentioning is that Grasshopper is very precise, so you can see we have 6 decimal places as a result here. So what I like to do is I actually like to round those up before I send them out to Revit. So under math, if you pick the expression tool, double click it, erase that, and use a rounding expression. So if you type in round, open parentheses, and then let's say that we're going to plug in a parameter called number, and then we're going to specify how many decimal places we want. So let's do decimals. So basically what this does, it takes a number and it rounds it up to this number of decimal places. So right now we have to just change that to match our parameters that we specified in the formula. So it's going to be a number, and then y is going to be changed into decimals. And then we just use that as a number, and then you can use a slider. So if I double click and type in any number, that'll make a number slider. So let's use a slider. And then you can start seeing the difference kind of side by side, before we rounded them and after we rounded them. So we have just 1 decimal place, or we can change that to, let's say, up to 5. And you can see the numbers change there. You know, we get 4 decimal places, 5 decimal places. But I just like to keep a 1 decimal place, because all of them are basically, actually all of them are made to be the same distance. So 1.8 should work for us. So this will be a parameter for that family that we're going to specify. So in order to do that, let's go to Revit tab and then use the parameter component. So that parameter component is going to go into the parameters of that particular family. The rounding distance that we just created will be the value that we're going to be pushing through, and then I'm just going to copy and paste the panel, and we're going to call this length. So this would be the parameter name that we want to push through. Once we have that, we should be good to go. So now we just gotta make sure that we create a family with this length parameter in it, and then a 2-point line will be the name and type for the family. So let's go to Revit, create a new family. and then you want to go to generic model adaptive, and this will be a 2-point family since we're creating just a line. So make those adaptive. You can just use this spline through points to draw a straight line between those. Make sure it's a reference line. And then the same process that we used before, which is I'm going to host 2 points on that line. I'm going to turn on their reference planes, and then I'm going to use those reference planes to hold a circle, and I'm going to give it a parameter. I'm going to keep them consistent, and it's going to be a type so that all of them get the same type, same radius. And then if you select those, and then create form, it gives you form, and then you got that pointer you can push around on that curve, on that line between those 2 points. So one of them is going to go in the beginning, and one of them is going to go at the end. So once we have that, we just gotta make sure that we add that parameter to it, and then make sure we save it as that. So let's add a length parameter to that family first. So under family types, we just add a new parameter. And if we wanted to schedule that, I can actually make this a shared parameter. And since I don't have any shared parameter file, I'll just create one, and I'll call it a Grevit test. So Revit's going to create a shared parameter file. It's a txt file, and then it's kind of empty, so we can add parameters to it. I'm going to create a group called framing, and under that I'm going to create a new parameter called length. But I also want to be more specific that it's a line length, not an arc length, because we might be specifying an arc length for the other vertical numbers. So let's do a line length, common, and then the length parameter. Hit OK. Change it to instance. Keep it under dimensions. So we are looking good on this one. And let's go back to Grasshopper again. Let's copy that to make sure that we save in it under the right name. Then again, I'm just going to drop it on the desktop, give this the proper name, load it into the project. You don't have to place it. So once we're here, we have it loaded. Hit the Grevit button, go back here, hit this one, go back to Revit, let it spin for a little bit, and here we are. We can start. We can see it. It looks a little bit awkward just because our family has an extremely large radius that we gave it. It's 2 feet 10 in radius. So let's make him, I think we made the previous ones 2 inches. So once we make it 2 inches, you can start seeing that it works pretty well. Let's see if the parameters came through as well. Actually, the light length parameter didn't get filled in. This is the reason why is, let's go back to Grasshopper. We changed the name. It's called line length now in Revit. While in Grasshopper we kept it as length, so it didn't make that the proper association. So let's change the name here to line length, and then let's make sure that we have, so this data tree needs to match this data tree. which is on the one single branch. So if we simplify this, they'll delete the excess branches. So this is another reason why this couldn't work. So now we have it simplified and the line length is correct. Let's go to Revit. And before we re-import it, let's just delete everything. So now if you come back here, there you go. So each one of those studs now reporting its own length. So here's how you do a instance parameter, and you assign it from Grasshopper. And since we made it a shape parameter, we can actually do a schedule from it. I can show you how to do that later. Stay tuned, there will be another video when I'm going to go over some more parameters and then maybe some scheduling for all those pieces. Thanks for watching.